Mic test. I think we are good. Um, what's up, everybody? Um, can you believe it? We are back with another stream, and what's today? Tuesday? Yeah, literally streamed yesterday. Jeez, feels like a long time, but I guess 24 hours is a long time to stream. Maybe I don't know, but um, welcome back, everyone. Today we're going to go over chapter 4 of Networking Essentials. And to just, uh, I guess, briefly review what we went over last week. Not last week, geez, yesterday. We talked about the types of wireless networks. We talked about 3G, 4G, 5G. Um, we talked about the different ways that a local area network can be made up of with host devices, peripheral devices. Um, sorry guys, give me one moment. Okay. Firefox is not completely playing. Okay, we'll do that a little later then. Um, we talked about host devices, right? Which are end devices. We talked about peripheral devices. These are going to be your webcam, your keyboard, your mouse, your local printer, your local scanner. And then we talked about network devices. These are going to be your switches and routers. And then we also talked about the network media, the way that um, all these devices are connected and how data travels, right? And basically, more specifically, how data travels, and that can be um, through Ethernet cables, through copper coaxial cables, through fiber optic cables, and of course, everybody's favorite Wi-Fi. And then we also talked about IP addressing, and we briefly talked about subnet masks, and but we more specifically talked about how IP addresses are assigned, and that can happen either through you manually assigning IP addresses or allowing DHCP to do it automatically for you. And DHCP again is Dynamic Host Configuration Protocol. And for most everyday users, it's already on and it just does its magic, right? And then last but not least, we talked about network topologies. That topologies are like the blueprint, the map, and then there's a physical topology, like the physical map, right? Where are these computers located in? And then logical topologies. When you think of logical, you think of IP addresses. But yeah, today we're gonna move on to chapter 4. And what are we gonna learn today? Well, we're gonna learn the types of cables. I know, not really too exciting, but um, in networking, you're gonna want to know the kinds of cables. And then we actually might, not might, we will talk about verifying connectivity with a nice thing called ping. For my gamers out there, you may know a thing or two about ping. So let's get right into it. There are three media types. There's the copper, um, well, more specifically, metal wires within cables. So these metal wires, this metal most likely is going to be copper. And metal wires, they transmit data through electric pulses. And then we have glass or plastic fibers, fiber optic, and then fiber optic uses light. And you know, nowadays, at least where I'm from, a lot of people are on, uh, fiber optic. Um, I specifically use Verizon Fios. I know Google has fiber optics. I know Comcast has fiber optics, and fiber optics we'll talk about a little later in this chapter. Why it's so fast and the advantages of it. Like, um, you know, there are fiber optic fiber optic cables that actually go through the ocean. I don't know if they'll mention that, but you can actually look it up yourself. That it's pretty neat that there are legit cables crossing the ocean. And then again, everybody's favorite wireless Wi-Fi and um, you know, wireless is going to be talking about, electric magnetic waves and radio waves and um, yeah, can't think of any more examples. Um, but yeah, let's get right into it. The types of network cables. I'm pretty sure everyone has seen these kind of cables, right? Your Ethernet cables. Um, they're also known as twisted pair cables. And the reason why they're called twisted pairs is because literally there are wires grouped in pairs and twisted together. And the reason they do that is so that it can reduce interference with each other, so that they don't touch each other. And they're in different they are in different colors. It's not really important to know the colors. Just know that twisted pair, literally like the name says, um, there are there are cables twisted in pairs, and the reason they are like that is so that they don't interfere and touch each other. Um, Coaxial cable. I think we all have seen these bad boys before. You know, if you got older television sets, that's probably where you've seen those plugged in. I remember DSL. Um, yeah, I had DSL and we had that DSL modem coaxialed up. And it's just basically just copper. Um, here's just let's see. It's a single rigid copper core that conducts the signal. The core is typically surrounded by a layer of insulation, braided metal shielding, and a protective jacket. Um, it is used as a high frequency transmission line to carry high frequency or broadband signals. I don't think it's as common to see, especially nowadays where, well, at least for where I'm from, right? I can't speak on the behalf of a lot of people, but where I'm from the DMV, the DC, Maryland, Virginia area, and a lot of people, are tech savvy or technologically updated, meaning that they have the Ring door cameras, they have smart TVs, they got um, like the smart fridges. I mean, everybody's like, this is at least this is how it is in my area. So it's not very common to see coaxial cables anymore. Um, I don't know about you guys. Maybe you guys still use it, but from my area, it's pretty rare. It's a novelty now. Because most people are now on fiber optic cables. I mean, don't get me wrong, Ethernet cables. I mean, I'm jacked up with my workstation. I'm using Ethernet, so um, but my internet service provider, Verizon Fios, is using fiber optic cables. I like literally I saw the worker. He literally just dug. I don't know how many feet. He dug pretty deep to set up the cable lining. So fiber optic cables, they use light signals to transmit data. And let's see, the diameter about the same is the diameter about the same as a human hair, and it can carry digital information at very high speeds over long distances. Because light is used instead of electricity, electrical interferences does not affect the signal. Fiber optic cables have many uses, as well as communications. They are also used in medical imaging, medical treatment, and mechanical engineering inspection. Another important thing is they have very high bandwidth. Again, we talked about it a couple of streams ago. Bandwidth, the capacity of the medium. So this means fiber optic, it can allow a lot of data to travel through it. Uh, Again, going back to the shower head example, the shower head, the larger the shower head, so we use water as the example for data. If that shower head is a small shower head, the bandwidth is small, meaning that not a lot of water can travel through it. But if you have a large shower head, that means it has a large bandwidth, meaning more water can travel through it. Let's see. Let's check our understanding. Which of the following is not a criterion for choosing a network media? The type of data that can be transmitted, the maximum distance that a media can successfully carry a signal, the cost of installing the media, the environment in which the media is installed. I don't think we really discussed the factors of why you would choose a specific media, but through the process of elimination, we can do this by the process of elimination, right? The type of data that can be transmitted. Um, I think this is a reason why you would want to choose a certain media, so probably not this one. The maximum distance the media can successfully carry a signal. This is probably another reason why you would want to choose a certain media, right? If you can use fiber optic, if you want long distance travel, you probably want to use fiber optic over Ethernet. So probably not this one. The cost of installing the media, maybe, and the environment in which the media is installed. So we talked about how fiber optic, because it uses light, doesn't get any electrical interferences. So I'm gonna go with the cost of installing the media through the process of elimination. And if we get it wrong, we get it wrong. But I think that's a good answer. What is the common type of wired media used by TV companies to connect and carry signals to set top box within a home? It's going to be a coaxial cable. Which type of wired media is used to carry digital information at very high speeds over long distances? Fiber optic. And which is the most common type of wired media to connect end devices to Ethernet LAN? And that's probably going to be our twisted pair. Let's check. Okay, so we got this wrong. Um, let's see. The maximum distance the media can. Okay, maybe it was this one. Nope. The type of data. Let's see. Um, Criteria for choosing network media includes the maximum transmission distance, the environment, and the amount of speed that data can be transmitted, and the cost of the media installation. Okay, so the type of data is not a criteria. Okay, moving on. Twisted pair cables. Let's see. This is not too entirely important. It's just talking about EMIs, electrical magnetic interferences, um, and the reason why they're twisted together, and the reason why it has a protective jacket over it. You can read this over yourself. It's not too entirely important. I mean, if you want to get into the nitty-gritty details, sure. But let's talk about the types of twisted pair. You have UTP, and then you have STP. UTP being unshielded twisted pair. This is the most common encountered type of network cable in North America and many other areas. It's inexpensive, offers high bandwidth, and it's easy to install. Um, so yeah, again, most common type in America you're going to see. And then we got the shielded twisted pair cable. This is probably going to be more found in Europe. And these ones, the reason why they're called shielded is because, well, obviously, they have better protected jacket, and it's probably more prone to EMI and RFIs, radio frequency interference, and electrical magnetic interference. But they're extremely expensive, and they're not flexible at all either. And then here are the types of these are going to be the types of um unshielded twisted pairs and shielded twisted pairs. Hey, Walking Wounded, how you doing? Sorry, last time for some reason my chat wasn't working, so I couldn't see your messages. But what's going on? Long time. We're just talking about the types of mediums. Um, and so RJ11 is the smaller one, and then we got RJ45, the larger ones. I think RJ11, if I'm not mistaken, um, or is it? Yeah. So RJ45, I believe, is going to be the more common ones that are used for Ethernet. You work in the knock? That's what's up. Maybe you can teach me a thing or two. That's dope, man. So let's check our understanding. A type of interference that occurs when cables are bundled together for a long length is known as, uh, I believe it's cross talk. If we get it wrong, we get it wrong. What type of Ethernet twisted pair cable may be required when the electrical environment has strong EMI and RFI? So this is going to be our shielded twisted pair. Again, fiber optic and coaxials are not even Ethernet cables. And then which of the following is the most common type of connector? I believe it was RJ45. Let's check. And there you go. 3 for 3. How you doing today, Walking Wounded? I guess are you working right now? You work at the knock. Cable, TV, and satellite cables. Oh, you just got off work. That's what's up, dude. I'm actually trying to get into the field. Not specifically in networking, but more trying to get into cybersecurity. So it's been a long journey. It's been at least 2 years since I've been trying to break in this field, and hoping 2022 is the year that actually happens. So let's see. Cable TV and satellite cables. So again, coaxial cables associated with the TVs. Again, for where I'm from, it's not too entirely common to see coaxial cables anymore. Like I said, it's kind of more like a novelty. Um, because now we're onto fiber optics. Um, at least in my area, a lot of places use fiber optic, and there's just a lot. It's just there's just so many more benefits with fiber optics. Obviously, it can handle the weather better, weatherproof. The it's using light, so again, you're not getting electric magnetic wave interferences, and data can travel longer. So Walking Wounded says most residential terminating points are switching over to fiber from decades of running as copper. Yeah, so you heard it from the knock engineer themselves. We are slowly transitioning away from copper, um, and we're in the era of fiber optics. I mean, who doesn't want faster internet? I mean, I don't know. I mean, I remember when I was on DSL and dial up. I mean, man, those were rough times. Those were extremely rough times. When you tried to download a game and it just took like 12 hours, so you had to like literally leave it overnight. And yeah, those were yeah, the struggle days. Yep, yep. Those were caveman days. Okay, so let's check our understanding. Which of the following is an advantage of coaxial cable compared to unshielded twisted pair? Um, uh, I want to say it's easier to install. Actually, no. Like with the Ethernet, all you gotta do is click it in. So maybe less expensive, maybe easier to troubleshoot. I mean, troubleshooting, I can't imagine all you're doing is just twisting it out and twisting it in. Let's let me go to question two real quick. Which type of cabling is immune to RFI and EFI? And we just talked about it, fiber optics. Well, actually, shielded twisted pair too, right? Which type of cabling is immune to RFI? Actually, immune. Let's say fiber optic. Um, let's go back and check. The advantage of a coaxial cable over a unshielded twisted pair. Let's see. Let's see. Like twisted blah, 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 provides improved shielding compared to UTP and therefore carry more data. So it seems like it can carry more data. All right. Um, I don't know. Let's ask the knock engineer. I don't think it's entirely too important to understand these standards. Maybe Walking Wounded, you can give us your expertise. Also, it's cheaper to run over longer distances on boost. Ooh, that's good to know. In your opinion, um, I don't know how important it is to understand the wiring schemes. Maybe you can give us some insight on that. Um, and then twisted pair transmit and receive pairs. Yeah, I don't think it's not that it's not important to not know these things. I just don't think it's like if you're gonna get into networking, like become a network engineer, I can see why you would want to understand how Ethernet cables work. I just don't think it's like too entirely important, in my opinion. I don't know. Like again, I don't know. Well, let's see. Let's read uh, the expert. Well, the standard rule is they cannot be under interchangeable, cannot be under interchangeably, but you generally just stick with one or the other. Okay, I'm sorry. Well, the standard rule is they cannot be used interchangeably, but you generally just stick with one or the other. Or if you're working with a stack that is already using one type, you just stick with that type. But largely it's unimportant. So the most important part is that if you're going to use if later on you work for a company and they're sticking with a certain cable, you're probably just gonna only need to know that specific cable, right? Again, I don't think it's important enough to stress over like, oh, am I gonna use T568A cable or T56AB cable? Like, I don't think it's like that. Yeah, don't start reinventing the wheel. Exactly. So, uh, I'm just gonna skip over this. It's not too entirely important. If you want to, by all means, please. But the ping command. This is for my gamers out there. The ping command. It's so funny. A lot of gamers are like, my ping is not good. My ping is not good. It's so funny how they use ping in that way. But ping is, um, we'll get into it. It is a layer. So in the OSI model, it is, or OSI and TCP model. It's the network layer, layer 3 protocol. Okay, and we haven't got into it yet, but I just wanted to put that disclaimer out there that we talked about MAC addresses, NICs being label layer 2. Ping is a layer 3 protocol, um, also known as ICMP, Internet Control Message Protocol, Internet Command Message Protocol, or is it control? Jeez. I don't want to, Internet Control Message Protocol. Um, yeah, so basically, ping is, you're just testing connectivity. And, I can give you here, let me pull up my virtual box. Let me see if I can pull up, let's see, let me pull up my CyberOps workstation. And I will show you, literally, live. Um, I can just show you, really. It's not that difficult. Um, you know, Instead of having, they have this video of host one pinging to host two, but you know what? How about I just give you a live demonstration of how this works? All right. So here's my PC. Uh, do 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 do. So let me ifconfig. So my Kali machine's IP address is 192.168.1.220. And let me see my CyberOps workstation. Let me iconfig. And my CyberOps workstation is in the is we and I know they're both in the same network, right? Because we talked about it last time. They're both in the 192.168.1 network, and this is the 221 host, right? So if I want to test, so let's say for example, host 1, my Kali machine, let's say my Kali machine is host 1, and I want to test, can I connect, well, in this example, they're in two different networks. So uh, my real life example isn't like, yeah, unfortunately, I'm not in a different network, but um, in this scenario, right, this H1 is going to send a ping and it's going to reach the router, and the router is going to see, okay, this is not in the network, and it's going to send it out through this interface, and then this router is going to receive and be like, oh yeah, I know where this is, and then it's going to send it to H2, and I can play it live. And bam, and it goes to the switch. Switch realizes, okay, this is not in our network, forwards to the default gateway sends it out, and then yeah, and then H2 responds, yes, I'm here, with the ICMP reply message. So again, just to show you, whoops, just to show you, and you know what was that one? Whoops, let me put this over here so that I don't get mixed up. So again, let's see. you'd ping the PC right below that one. Are you talking about H1 would yeah, yeah, exactly, exactly. Thank you, Walking Wounded. Yeah, so in this example, my real world example, yes, Walking Wounded, excuse me, thank you. I would be basically pinging this dude. We're in the same network. So, uh, let me, and I, I haven't shown it yet, but there's this tool called Wireshark, and we can see live action. Well, let me make sure I click this, and I'm gonna filter out for ICMPs, and let me just go ahead and ping. What was it? 192.168.1.221, and let me just give it a count of 4. Uh, so yeah, let me go ahead and run that command, and we can see that uh, I have connectivity. Well, we knew that, first of all, we know that we have connectivity because it says 4 packets transmitted, 4 received, 0% packet loss. Um, Sometimes if you're in a different network, you may get like a couple packets lost. But so that's one way to know for a fact that I have connectivity. I just wanted to show you with Wireshark that this Wireshark is a something called a packet sniffer, right? We'll talk about that a little later. But yeah, we can see here's the source 192.168.1.220, and remember that's my Kali machine, and our host on the CyberOps is 221. And then we can see that my Kali machine requested, and then the CyberOps replied, and then we can see that that repeated 4 times. So yeah, that's ping, and then there's something called trace route or tracert or is it netstat_r? I don't think it's netstat_r. But trace route. Anyways, trace route and tracer. Basically, it's just going to basically tell us how many hops it took for our packet, our message. Um, how many hops did it take, right? So, for example, if I wanted to ping google.com, or actually let me trace route google.com. It took my it took me, let's see, one, and then this one right here, I believe is the firewall. Um, but ultimately, it took 9 hops for my workstation to connect, or not to connect, but basically communicate with Google.com. So again, you're just counting the amount of hops. And a hop is literally one router traveling to the next router, traveling to the next router. So that's a hop, right? So this router going to this router, that's 1 hop, 2 hops, 3 hops, etc. And then, yeah, that's that. And that's chapter 4. Thank you, Walking Wounded. It's kind of nice to have, it's really nice to have a knock engineer. I mean, this is dope. I mean, this is really, really dope. I really appreciate your time for just, stopping by and, you know, being a cool cat and sharing your knowledge and expertise. Um, but yeah, that is chapter 4. Let's see. Not all devices along the path may respond to ICMP, so you may see drop tops among one of the reasons why you might see yeah, that is a good point. That is a really good point. Um, how do I word this? So there may be some routers that are configured, or not routers. Maybe there are some networks that have firewalls that are configured, set up so that they don't accept pings. And that is, again, yeah, that's a great point. That is one reason why your ICMP get a response. Um, for the most part, I believe. I'm not sure. I want to say most firewalls are set up by default to not accept pings, but I could be completely wrong. Um, but that is a great point. Thank you, Walking Wounded. That is a great point. So, yeah, that is chapter 4. Chapter 5, we're going to, what is chapter 5? Okay, so yeah, chapter 5. So we talked about it a little bit in this stream, but we will get more into it in chapter 5 about I did briefly mention the TCP, IP, and OSI model, if I can find yeah, so this is what I was talking about. We'll talk about it next stream, but this is important. This is really important to understand, especially if you're gonna get into networking or get into cybersecurity. You must understand the TCP/IP and the OSI model. So I did mention OSI model. Ping is a uh, you were right. You generally want your firewall as dark as the internet possible within reason. Thank you, Walking. So yeah, Walking Wounded again, giving confirmation. Hey, what's up, Ducky? Sup, dude? Um, Walking Wounded, we got the knock engineer experts confirmation. So yes, you generally do not want to be visible to the internet. You want to be as anonymous as possible, right? But yeah, ping layer 3. And we talked about NICs and MAC addresses. That's gonna be layer 2. But yeah, that's next stream, guys. Just for the most part, I mean, there's not too much to digest. I mean, we just literally talked about cables, but yes, um, just know your different kinds of mediums, and yes, like Walking Wounded said, you do not want to be visible in the internet, right? So like, you do not want, for example, you don't want to go on, you don't want people knowing your public IP address, right? You don't want people knowing your public IP address, right? What is my You don't want to go on stream and type in what is my public IP address? Um, what is my public IP address? Are you gonna give me? Wow, Google is even protecting me. What is my IP address? IP chicken. Oh yeah, so yeah, again, you don't want to go on the internet and or stream. You don't want to be doing what I'm doing right now and showing the entire world your IP address, right? Because now, if there's any attackers out there who's going to, um, they can DOS me and things like that. But I know, Walking Wounded, there's some people, you're probably thinking to yourself, like, what the hell are you talking about, dude? You're just giving away your public IP address. Guess I'll just nmap this real quick. Don't worry, guys. This is not my public IP address. Okay, this is not my public IP address. Okay, I'm not using a VPN. I'm using proxy chain. So don't worry. You can nmap me. You can try to find my location. I mean, for the, I mean, if you want, I mean, look, if you want, yeah. I mean, was that even my IP address? See, look at that. I mean, it says, well, this is not even my. This is not the I. This is definitely not. Well, that's definitely not my. I guess that's my DNS server's address. I mean, whatever, right? You're not gonna find me. My point is that go ahead and map me, try it. It's funny, but I mean, supposedly I'm somewhere in Luxembourg, Germany. But yeah, yeah, you can have mine. Oh man, guys, we got Walking Wounded's loopback address. Go ahead and ping his loopback. But yeah, again, you want to be as invisible as possible to the internet. So, but yeah, I mean that's pretty much all I had today. I guess I can show you a little cool thing, right? I guess I can show you a little cool thing. So, before I end the stream, I can just show you something real cool, right? So we use something called Wireshark, right? This packet sniffer, right? So let me actually stop this and let me start a new one. Continue without saving. Let me uh, put this. So we saw that um, we saw that my Kali machine 192.168.1220 when I pinged my work CyberOps workstation, we saw that that this was my Kali machine, right? So there is a tool that can spoof my IP address, so that way when I do ping, it won't know it's me. Um, so yeah, I can I can show you that real quick. It's called hping3. Uh, that is okay. So let me put that, and the command is called hping3, right? And if you want, I can man it. Man hping3. Okay. I don't know if you can read that. Let me see if I can make it. I don't know if that even made it bigger, but let me see. View. Hmm. For some reason, my control plus does not work and won't let me zoom in. I'm gonna have to research into that. But um, basically, um, I'm gonna use the flag number one to indicate ping. Um, you can use flag C to give the count, right? So if I did number one C and if I wanted to give it a count 4 or 5, that's like 5 packets. But what we're really interested in is um, spoof. So if you wanted to just spoof yours, you can give yourself a certain IP address. But let's do rand. I'm gonna use this called rand source, and um, let me show you how this works. So we got hping3. I'm gonna give it the one flag for indicate that it's a ping. And instead of giving it a count, how about I just want to flood. I just want to attempt to it's gonna be a weak DOS, but nonetheless, I want to flood this person. Um, and then I want to do was it rand? I think it was rand source and give it the IP address 192.168.1.221. And are you ready? Uh, okay, sorry guys. I believe I have to sudo it. Um, or it could be either that or I'm putting in the wrong flag. Let me try it one more time. Okay, yeah, no, actually, I put it in right. And let's see. And there you go. Bam! And you see my CyberOps workstation is just getting flooded. And if you see, uh, let me let me stop it real quick. Different source ports. Um, I think you can specify that. I'm not too entirely sure if it's using different source ports. Um, we can always, I guess we can see inside the packet real quick. So yeah, like it's pretty funny. Like look at all these different IP addresses. Um, like look at this. Let's see. If we go into the layer 3, actually it would be layer 4, correct? Actually, what is this? This is the I don't because it's ping. Is it gonna give me Yeah, there's no port, right? Because port is gonna be layer 4. The RAND source flag, it's basically it's using um just a combination of random sources. So if I ran this command instead of using RAND source and this spoof, I would have to identify which IP address I want to use to substitute my actual IP address. Um, yeah, exactly. Pinging from different IP address. Yes, RAND source. That flag is just use because I'm flooding. I just wanted to send just different sources. So yeah, that's a cool little. Yeah, nice. Yeah, it is. It's a little cool trick. Um, I pull it out when I want to feel cool. But yeah, that's one way of spoofing yourself. But yeah, I hope that was yeah, that's that. But yeah, that's all I pretty much had planned for today. I'm actually shocked that we went 48 minutes, but yeah. Next stream, we'll get into the TCP IP OSI model and the protocol stack. And yeah, so yeah, right on. No, thank you for stopping by, Walking Wounded. I really appreciate you. Um, Appreciate everyone that stopped by. And yeah, uh, I really enjoy this. I hope that you had a good time. I know I did. And till the next time, peace.